Hello students, welcome in our chapter 6 AOD, application of dairy. Students, today we continue our exercise 6.5 in the further numericals for maximum and minimum value defined in the particular functions. So question number 5th going ahead today. X cube minus 6x square plus 9x plus 15, find out maximum and minimum values. So very easy students, you know that there are the 4 basic steps. So my first steps is that antecedents and antecedents is that 3x square, 6 to the 12x plus 9, and next 6x minus 12, 9 and 0. Now students, continue my step 2. Very simple. If first array equal to 0 taking, so 3x square minus 12x plus 9 is equal to 0. 3 common cutting. You have to only x square minus 3 4s are and 3 3s are. But 3 never 0 students. And here making the split. 3 1s are 3. It is x minus 3, x minus 1. So you have to one of the answer 3 or x is equal to 1. And these two values, now I am going to check it. Yes, in step 3. So students, continue our step 3. And x is equal to 3 and same as and x is equal to 1. We define our checking and also step 3 with step 4. So now students, f double dash x. Our known the value 6x minus 12 and put down the 3. So 6 3s are 18. 18 minus 12. The 6 greater than 0. So definitely at x is equal to 3, fx is local. Greater than 0 means local minimum. And last step 4. Very easy. Yes, step 4 is nothing. You go to original our fx. X cube minus 6x square plus 9x plus 15. And here students apply your x is a 3. Just to get answers. So here students 3 cube 6 3 square 9 3 plus 15. Now answer. 3 cube is 47, 9 6 are 54, 27 and 50. 27, 54 common. So my answer is 15. Same calculations at the place of n x equal to 1. So students, same application of f double dash x. You can derive your f double dash 1 value. Yes, answer is minus 6, which is less than 0. And that is called our local maximum. Therefore, at x is equal to 1, fx is local maximum. Now, step 4 same belonging at that part. Yes, here step 4 is applying the fx. X cube 6x square 9x plus 15. Apply the value x is equal to 1. So students, my answer is easily known. 1 minus 6, 9 and 15. Now 9 and 10, 10 minus 10 and 15, 45. 45 minus 6, 19. That is your f1. Yes. So these are the defined maximum value. These are defined minimum value. So what is minimum? Sorry, this maximum, this minimum. So here write down it is global, our minimum, and here it is global maximum. Students, it is nothing on y-axis. Value is 19. If you put it x point is 1, and here y point is 15. If you put it x is a 3. Easily done. Now continue students, one more, 6th one. X by 2, 2 by x. Only x greater than 0. Means only find my answer. So step 1, g dash x. It is 1 by 2 and 1 by x is a minus 1 by x square. Second derivative also must be 2 is 0 minus 2 and that d dx of x raised to minus 2. So what you get? Minus 2x raised to minus 3. So it is 4 by x cube. That's your g double dash x. Now students, I am going ahead step 2. If g dash x is equal to 0 taking and simple, apply your g dash x value half minus 2 by x square is equal to 0. So simple, 1 by 2 is equal to 2 by x square. It is x square is equal to 4. So x is equal to what? Plus or minus 2? Yes, correct thinking. But x greater than 0. So I only write down 2 if x more than 0. So here students, our first steps and the second step that. Now step 3. And x is equal to 2. We can check in g double dash x. Students, double dash derivative only purpose for checking its maximum or its minimum. Okay. So my value is g double dash x 4 by x cube. So g double dash 2 4 by 2 cube. Cube is 8. So 4 by 8 half. And surely it is greater than 0. Therefore, gx is local minimum at x is equal to 2. And last going my step 4. Yes, step 4 is very simple. Applying the gx. Your gx is x by 2 plus 2 by x. And operate the value. You have to only 2 because already you defined the local value. G2, here 2 by 2, 2 by 2, my answer is 2. That's your local. After that checking, it is your local. After that, our value for global minimum. Yes, it is global minimum. And that also simple over here students. Question number our 6th one. Now one more students, same questions, 1 by x square plus 2. Similarly going, our step 1, g dash x. So your d dx of 1 by x square plus 2. So here denominator, numerator derivative 0, minus numerator, here 2x plus 0 and by here the whole square. In short, you can get it minus 2x by x square plus 2 whole square, my first derivative. Yes. Now I am going ahead also g double dash x. So here d by dx of our data 2x by x square plus 2 whole square and then operate against derivative. So g double dash x here in denominator square is 4. Now denominator, numerator derivative 2, x is 1. Minus 2x, here 2 with the x square plus 2 raised to 1 power into here 2x, 2 derivative 0. Let them as it is, don't worry. Now our step 2, if g dash x is equal to 0 taking. Students, here I only just mentioned the derivative u by v rule. So, if g dash x is equal to 0, so minus 2x by x square plus 2 whole square 0. This is already cutting with 0. You have to minus 2x 0. But minus 2 never 0. Your answer is only and only x is equal to 0. Now, step 3. At x is equal to 0, we checking g double dash x. We have to z double dash 0. You just put it here. X value is 0. So my answer is a minus 8. Here 0 plus 2 whole square into 2 is permanently 0. Because 2 into 0, total 0. And last value 0 plus 2 whole square raised to 4 power. So my answer is what? 2 square 4. And 4 2s are our 8. Yes, by 2 square 2 is 2 4 16 minus half less than 0. So confirm at x is equal to 0, gx is local maximum. That's students, you create your answer. Finally now going to step 4. Again applying gx. Yes, in step 4 my gx value is ready. What is that? 1 by x square plus 2. Apply here is easy. Putting the value, easily get answer. Yes, 0 plus 2. And that's your its global maximum. And here students, this numerical is also happily done here. Now students, coming to IMP questions. This is the most IMP numerical in the exam. So you tick mark in IMP list. Question is condition given 0 to 1 answer related. And find out maximum and minimum. Same way, our step 1. First derivative. So x. Second derivative plus now second. First derivative. I just operate here students. Our u into e. So what you get after x? Root derivative 1 by 2 times. And 1 is 0. But x is 1. Similarly here students, under root 1 minus x. Ddx of x is 1. Now you take two possibility further solutions by taking LCM. So x into minus 1 plus 2 times 1 minus x upon that was same. So what you get finally minus x 2 here 1 minus x. That is same. So finally you getting one derivative over at the x students here minus x 2 minus 2x. And that will be same. So what's your adjacent? Here 2 minus 3x by under root 2 series. That's your first derivative. Now I go to second order derivative. So continue by step 1. F double dash x. Students, it is d dx of 2 minus 3x by 2 under 1 minus x. It means again division. Yes. So F double dash x and denominator square. You have to know 4 and 1 minus x. Now numerator derivative 0 minus 3 minus numerator derivative d dx of denominator. Actually here not writing derivative because it is completely 0. So step 2, if f dash x equal to 0 taking, students, this is known as a formality for step 2. This first derivative I just take 0. So 2 minus 3x by 2 under 1 minus x 0. This totally cutting 0. You have to only 2 minus 3x 0. So what is the x? 2/3. And check this 2/3 is belong or range? Yes. This belong in the interval. And here your step 2 done. Now continue with step 3. And checking x is equal to 2/3. F double dash x. Students, this double dash x 3. If you put it here, it is 0. Only you know this number. So I just operate my data. 2 1 minus 2/3. Here put it up. 1 minus 2/3 into minus 3. Here 0 and upon same 4 1 minus 2/3. And that value checking either they positive either they negative. So my answer is students permanently here 2 1 minus 2/3. It is under root 1/3 into minus 3 upon 4, and that is 1 minus 2/3 is a yes, it is 1/3. Finally this all answer is definitely less than 0. So students, you can write down here and double dash x is less than 0. So after that I show up my answer. It is a local minimum or maximum? Less than means maximum. Yes, students. So after that I going one more steps in the checking values. So at after that you write down at x is equal to 2/3. Fx is local. What? X is 0 means local maximum. And now going to step 4. So students, continue my step 4. In the fx, you just put down your values. My value is 2/3. Only apply that 2/3 under root 1 minus 2/3. So your data is 2/3 and 1 minus 2/3 is 1/3. So very easy. It is 1 by root 3. Yes. Here just taking only for conjugate. Root 3 by root 3. How much root 3 root 3? 3. And into 3 is 9. So my answer is 2 by 9 root 3. It's the final answer for your y-axis related value. It is a global value for maximum. It is global maximum. Either you can write down absolute maximum. It is also correct. Yes, students. Now, students, very interesting question coming. Prove that following functions not have maxima or minima value. There are the 3 questions. All are very easy. Yes, step 1, step 2, step 3, step 4 I followed. First question, fx e raised to x. So my step 1, students, f dash x, f double dash x, it is nothing, e raised to x. E raised to x. Now step 2, if f dash x equal to 0 taking, so my value is e raised to x is equal to 0. But it is not true, because every exponential function never be 0, never be negative. E raised to x not equal to 0. It means value of x does not exist. They are not possible. X not possible, so we cannot check in the double dash. It means they do not have maximum and minimum value. Yes, therefore fx e raised to x have that do not have any maximum or minimum. I mean, minimum or maximum value not existed. This graph is only going ahead, not they intersect with x-axis, not they intersect with y-axis. Yes. Now continue to second. Gx log x basic. Same here I am doing step 1. At g dash x 1 by x. G double dash x, students, minus 1 by x square. Now step 2. If g dash x is equal to 0. Very easy. G dash x is equal to 0 means 1 by x is equal to 0. Then not possible. Because 1 upon x, 1 upon 0, not possibility value. So 1 upon x never 0. So it is a false. Either you can write down not equal to 0. So you say write down value of x does not exist. So conformly, here x, then gx. So gx is equal to log x base z. Do not share any, what? Any, yes, maximum or minimum value. The graph is also moving to upsides, but not intersect with x-axis and not intersect with y-axis. Now third, x cube, x square, x plus 1, same application. Students, step 1, take down the x, 3x square, 2x, 1. Now h double dash 6x plus 2, and here 0. Now taking first derivative here. So step 2 is my h dash x is equal to 0, taking. So students, you have 3x square, 2x plus 1 equal to 0. Now here wait, you define your value of x in real numbers. because x-axis and y-axis both are in real number exist in the level of maximum and minimum values. Okay, so I go in here complex either quadratic equations. You know the quadratic discriminant b square minus 4ac. So 2 square minus 4, 3 into 1. So 4 minus 12. Yes, 2 square 4 and that is 12 less than 0 minus 8 value. So here no real solution. Students, real value of x not defined. It means x value not defined. It means maxima and minima not possible. So here also write down, therefore value of x belongs to R, not exist. Therefore hx do not have, same apply, write down hx do not have any maximum or minima value. And here students, our 3 questions happily done. Now students, continue same questions. 5th one. Find the maximum and minimum our absolute value. Topic same. Going same ahead, our 4 steps. So in the question is that fx is equal to x cube, but in interval given minus 2 to 2. It means minus 2 values are included and plus 2 values included in the last answer. So students, my step 1, f dash x and f dash x. 3x square, 6x. Now students, continue ahead, step 2. F dash x is equal to 0 taking. So 3x square equal to 0. But 3 never 0. You have to only x square 0. X 0. Check. This x 0 is lies in your given interval. Yes. It is the belong to interval. Next. So I going ahead step 3. First of all checking yes, at x is equal to 0. I just check out double dash x. 6x. F double dash 0. 0. It is neither greater than 0 nor less than 0. It means this value is not possibility to cover local maximum, local minimum. Yes, global exists, but local not exist. So, at x is equal to 0, fx have not local maximum or minimum. Local I tell you is not only the related x-axis value. Yes, y-axis possibility. Students, here step 4. Yes, step 4 put it in the fx. X cube, you operate 1 by 1. 1 of the 0, minus 2 and plus 2. And x is equal to minus 2. And x is equal to 0. And at x is equal to 2. These are the y-axis value I defined. Yes, students, f minus 2, f0 and f2. Check what is the highest and what is the lowest. This is the highest. It means it is a global maximum, either absolute maximum. Those two things same. So here it is your absolute. Yes, this one. Absolute maximum. And here students write down it is absolute minimum. Either you can write the word here global. Global maximum, global minimum. Okay? And it is a local. Local means point on x-axis related. And global means what? Point on y-axis related. And that's students here simple question first over here. Now continue students. One more IMP questions. These are exam level. So tick mark in IMP list. Sin plus cos 0 to pi. Yes, only boundary 0 to pi. So my step 1, f dash x double dash 2 derivative taking sin derivative cos or cos derivative minus sin. Next, cos derivative minus sin, and here cos sin derivative. Now students, continue step 2. If is equal to belongs to in the interval. Yes. Now I am going ahead slowly. Step 3. Yes, add x is equal to pi by 4. Students, I am just checking about to f double dash x. This is double dash x. Minus sign, minus cos. F double dash 45 degree. You must be checked. Yes, sin 45, cos 45, minus 2 by root 2 means minus root 2 less than 0. It means yes, students, my answer. Yes, therefore at x is equal to pi by 4. Fx is what? Fx is local. Less than 0 is maximum. Fx is local maximum. And now after that go to step number 4. So continue, students. My answer is going ahead. Step 4. At x is equal to 0. Must be 45 and pi. 3 value I declare and that is global values. So at x is equal to 0, at x is equal to 45 and at x is equal to pi. These all have fx I know. To just one by one. Fx is sine plus cos. It means sine 0 0 cos 0 1. This first line. Now secondly, students, fx here f pi by 4. It is sine pi by 4 plus cos pi by 4. Now sine 45, cos 45, it is root 2. And third, at x is equal to pi, your fx in the f pi, sine pi plus cos pi. Sine pi 0 but cos pi minus 1. Now you can check at when your value is highest. Yes, root 2 is highest, is more than 1, and minimum is a minus 1. So I just write down f pi by 4 root 2 is absolute maximum, and similarly going f pi minus 1 is absolute minimum. Either you can say it is a global minimum, global maximum. Yes, students, they are happily here this question is a done. Continue, students. Question number 3. Fx 4x minus half x square minus 2 to 9 by 2. Same way, step 1. Your first derivative and second derivative. First derivative is of 4. X square had 2x. So you always just getting 4 minus x to be cancelled. Now second derivative. Here 4 0, x is 1, and it is surely less than 0. Now step 2. F dash x is equal to 0 taking. So very simple. Your f dash x is a 4 minus x. So what is x? X is a 4. Now continue step 3. And x is equal to 4. We just check about f dash x. My f dash x is a minus 1. Nothing changed. So at x is equal to 4. Fx is what? Local maximum. And now going to step 4. Step 4, just I write down here, students. Because the all values are declared minus 2. Next 4. 4 is belong there, students. Minus 2 to 9 by 2. And after that 9 by 2, 3 values I 1 by 1 declare. So first at x is equal to minus 2. What is my fx? Fx is a 4x minus half x square. Students, putting there minus 2 in place of x. So your data is covered to minus 2. Here minus 2 square. So 4 to 8. And here 4 by 2 to minus 10. Same as going to tan x is equal to this number. How much? So here apply 4. F4. 4 into 4. Half 4 square. So 4 4 is 16. And that is 16 by 2, 8. And last, add x is equal to 9 by 2. So f of 9 by 2. Similarly apply and value 9 by 2. So here 4 9 by 2 minus half 9 by 2 the whole square. So my answer is 2's are cancel, 9 2's are 18. And here 81 by 4. 4 is 8. 18 minus 18 by 8. So 18 8's are. Yes, 18 8's are. So 8 8's are 64. 6 carry 14. Yes, 144 minus 81. It is 63. Yes, 63 correct. No, 3 and 1 4 and 14. Now check. Overall all have what is the highest? Highest is 8 because it is less than 8. So here I write down it is absolute maximum. After observe this all three, and what is minimum? Here minimum. Yes, it is absolute minimum. And that, students, this question is also happily done. Now continue, students. Question number 4. Fx given x minus 1 whole square plus 3 in interval minus 3 to 1. Same application. Step 1. First derivative. Then after second derivative. Here 2. X minus 1 plus 3 is 0. X is 1 and 1 is 0. So now second derivative. 2 1 minus 0. Oh, it is permanently positive. So it is minimum value exists. Yes. Now step 2. If first derivative 0 taking. So what is the first derivative? 2x minus 1 0. But 2 never 0. So you have to only x is equal to 1. Now check. This one is actually belong your range. Yes. Then your correct answer. Now students are going to step 3. And x is equal to 1. Be checking to have double dash x. So 2 f double dash 1. So f x is equal to 1. Fx is local greater than 0. It means local minimum. And now I am going ahead to next one. Our step 4. Students, I hope you understood that type method. It's very easy. And after that, I go into in the word problems. Yes. And now step 4. What is step 4? Add x is equal to minus 3. First operator. Then after one, already one present here. So only two numbers is defined. Fx x minus 1 whole square plus 3. So my answer is minus 3 minus 2. Minus 3 minus 1 minus 4 whole square 16 plus 3 19. And at x is equal to 1 fx. You just put it down there. Only 1. So 1 minus 1 whole square plus 3. Yes, your answer is 3. So minimum value 3, maximum 19. Yes, that already declared the express one is a minimum. So f1 equal to 3 is absolute minimum value. Either you can write down the word global. And next, f minus 3 is 19 is absolute maximum. And here students, our this questions related to your all 4 questions happily done. Now students, after that question 6, 7, 8, 9, 10, 11 and 12 till up to 12. Yes, already we calculated in previous part. And after that students, now question number 13 word problems I explain you in the next part. Yes students, this part is stopping here and further explanations for word problem related. It's very interesting questions I explain in the next part. Okay, bye bye.